Let's review. The impulse momentum theorem says that a net force applied to an object over a certain time interval will change the momentum of the object. It is a restatement of Newton's second law. And there's the equation: F times delta t is equal to m times delta v. Recall that the left side of this equation, F times delta t, is a term we call the impulse. Hence the name impulse momentum theorem. A better name might be the impulse change in momentum theorem. A 255-gram ball traveling 12 meters per second to the right hits a wall and rebounds at 12 meters per second back to the left. If the ball contacts the wall for 0.18 seconds, find the force of the wall on the ball. Incidentally, the ball was probably thrown by a guy named Paul at a mall in the fall. That's all. We're going to use the impulse momentum theorem. We want to find the force, so let's divide both sides by delta t. The mass, you recall, in the SI system is best expressed in kilograms. So 255 grams is not going to be okay. Let's go ahead and write this out then. 0.255 kilograms, and then the final velocity is 12 meters per second. The initial velocity is 12 meters per second, so 12 minus 12, and the time is 0.18 seconds. Wait a minute. Something's wrong, because this delta v, 12 minus 12, is 0, which means the change in velocity was 0. There was 0 change in velocity. We must remember that v is a vector. So this setup is wrong. What we need to do whenever we have things going opposite ways, we need to choose a direction to be positive. So in this diagram in the upper right corner, I'm going to choose to the right to be positive, which means initially I will have a velocity of positive 12, and at the end we'll have a velocity of negative 12. So we're going to rewrite this expression, v final being negative 12 meters per second minus the initial velocity of positive 12 meters per second. And hopefully you can see now between these parentheses that the change in velocity will have a magnitude of not 0 and not 12, but 24. And that gives us a force of negative 34 newtons, meaning negative 34 newtons in which direction? To the left. Because again, if you look in the upper right corner, I chose positive to be to the right. Well, clearly, if the ball was traveling right and then bounces back to the left, the wall must have a force on the ball to the left, which is in the negative direction. Final thoughts on the impulse momentum theorem 3. When doing calculations involving momentum, it is very important to keep in mind that both velocity and momentum are vectors. The choice of which direction is positive is arbitrary, but realize that your choice of which direction is positive and which is negative applies to both velocity and momentum for that problem.